Periodic table, chill.
I understand. That was me.
Now we gotta do all of them.
20.
And we went over our packet, not went over it.
Super duper easy. You're gonna have to. Nope.
All right, ladies and gentlemen. So, if we were to put all four variables into a gas law, what would it look like?
P times V over T times N.
So, P times V over T times N.
Yes, no, maybe? I don't know.
Well, why?
I agree.
Because T and N are always on the bottom.
Okay. And P and V are always on the top.
Mm-hmm.
So what would that equal, ladies and gentlemen? That would equal a constant, correct?
So smart.
Why do your K's look like that?
Just the way I write them, sorry. Okay? So, in reality, what this would mean is that P1 times V1 over T1 times N1 would equal what?
P2 times B2 over T2 over T2 N2.
Is there anything else we could put into or change about this formula? No. Now, do we ever know the volume of a gas? Never?
If they tell us, or if we solve for it.
I've never given you any way of knowing the volume of a gas? Never? Never.
Problem.
I'm still up here walking, looking at you.
You can solve for it, can't you? 22.4 liters?
What?
You can solve for it, 22.4
When
liters.
is it 22.4 liters?
What?
When is volume 22.4 liters?
1 mole.
Okay, and
STP.
an STP. So wait a minute. STP gives us a what and a what?
Pressure
A pressure
And the temperature.
and a temperature.
Okay.
And then if we know the volume, we could know how many moles.
Mm-hmm.
and that'd be all
So that would be what?
four.
That would be all four of them? All four.
Yeah.
So all four. So give me a pressure, a standard pressure.
760 mmHg.
Okay. Now what would be standard temperature? What's standard temperature?
Like room temp? Or
No. Remember we said it was a certain number. Anybody remember what the number for standard temperature was? Freezing point of water.
0 degrees Celsius, 273 Kelvin.
So 273 Kelvin. Now what would be the volume of the gas?
22.4 liters.
Assuming what?
1 mole.
1 mole. You got everything there, don't you?
But that's just like the combining ones because 1 mole, like, that doesn't change anything.
What?
What you have on the left is just like the combining ones. That's that exact same equation.
Here?
Basically, well, the one on the bottom because 1 mole is like nothing. It won't change it, right?
Well, hang on a minute. Well, this 22.4 liters, this volume, is only true if how many moles?
1 mole.
What would happen if you had 2 moles?
44.8.
What if you had 3 moles?
Oh, that's too much. Sorry.
Not like it's a number. We could do a little addition here since the 2 numbers above it would total up to 3.
Like
67.2.
There we go.
I know it's 67.
What if we only had 0.5 mole?
11.2.
Are you crying?
What's V divided by N here? What is it here?
22.4. 22.4. 22.4.
So this ratio never changes at STP, does it?
No.
Gives us the same constant, right? Is there anything else I can put into here? No, that's all of it, right? And when I multiply all of these together, ladies and gentlemen, you can trust me on this. If you want, you could do the calculation. That's what you get.
I trust you.
What is that, according to this formula?
Constant.
And guess what?
What?
This one don't change. That is a true constant.
So like no matter what we put in for those, it's always
No matter
that, or
what you put in for those, that's your true constant. That is your true constant, ladies and gentlemen. Now the problem is, what could we change in that formula?
the amount of mole.
Nope. Because if we did, we would have to change the volume of the gas. Right? So if we were to put in 2 moles down here, what would we have to put up here?
42.8.
Which would still be this same number, right? That same ratio. So guess what? Wouldn't change this. What could change this though?
Pressure.
Why?
Good question.
Like how could the pressure change, or
Why would it? And it doesn't really
temperature
change.
changes, or
It doesn't really change. Is there any other unit I could use here?
Oh,
What?
no.
atom?
Change it to things.
No.
Well, for me to go to N though, I have to be in moles. Now there's another way I could get to moles. I could give you grams of something, right?
Oh yeah.
But you would have to get it into moles. But there's no other unit for moles. That's the one unit, correct?
Yeah.
Is there any other unit I can use here in gas law problems? It has to be in Kelvin, correct? Volume, yes, I have other units,
Oh.
but not if I'm using the mole here. Now I have to be in the volume for liters, correct?
We have other measurements of pressure.
We do have other measurements for pressure.
But can't you do it like 22.4? Can't you do milliliters? Just multiply it by 1,000.
Right, but what I'm saying is in this formula here, for 1 mole, if I did it in milliliters, it would be a larger number, right? But if I got it into liters, it would come back to this same one. Correct? Okay? So, but this one, I've got 4 values for it, don't I?
Yeah.
So guess what? We have 4 constants, ladies and gentlemen. We have 4 constants. Ideal gas law, ladies and gentlemen. We put in all standard conditions. Every one of them we put in a standard condition for. Here's our pressure. Here's our volume. Here's our amount of gas. Here's our temperature. R is what we call a gas law constant. And when we calculate R here, we get 62.4. And guess what? R can never change. It is a true constant. But what we could do is we could put in a different unit of pressure. The volume wouldn't change. The moles wouldn't change. The temperature wouldn't change. But the R value would. Now you're sitting there going, wait a minute, you just told me R was a true constant. How can it change? If you have 4 quarters, Alexis,
No.
and you have 10 dimes, Yuritsi, how much money have you got? 10 dimes.
10 times 10.
I want to be your banker someday, people. I really do.
She figured it out.
How much? 10 dimes. How much?
100. Right?
100 cents.
100 cents. That's
Okay.
the same thing as it all.
Okay. And how much do you got?
$1. 100 cents.
Yeah, you both have the same amount. How can your numbers be different? You have 4 quarters. You have 10 dimes. How can they be different?
The value.
The value of the coin.
Because they're different units.
The value to unit.
So 8.31 kPa times liter 10 mole per Kelvin is the same value as 62.4 for using the unit of millimeters of mercury. So you remember how our 4 pressures were all equal to each other. This pressure is equal to this pressure, is equal to this pressure, is equal to this one. They are all 4 the exact same, correct? No.
Do we have to memorize all this?
No, you have a periodic table. You can write it down on it.
Yeah, you're right.
Okay? So if all 4 of these are the same amount, just expressed differently, what does that mean for all 4 of these? They are the same amount expressed in different units. What's another way of saying a mile?
I don't remember.
Something 4 laps.
Something feet.
I don't know. My
1600
GPS always
meters.
says kilometers, so I guess I'm
Right?
1600 meters.
Actually, no, it's not. It's not
800 meters?
exactly 1,600 meters. It's actually 1.61 kilometers. Thank you. 5,280 feet. 1,760 yards. All 3 different ways, 4 if you throw in the kilometers, of expressing the exact same distance. The distance doesn't change. The number does, the unit does, the distance doesn't. The value is still 1 mile. The value of all 4 of those R values is exactly the same. Now, I am not telling you you have to do this, but I am not giving you R values on a test.
These ones?
Those.
We have to memorize them.
No,
Periodic table.
you got a periodic table. I would write them down. But you better make darn sure you put the units with them. Because if you're working a problem with pressure and you use kPAs and you do not use this R value, guess what? It will not work out. Because the units will not be the same on both sides. Okay?
What is R?
R is the true constant for a gas. The true constant. Not one of these constants that as long as you don't change the temperature and don't change the number of moles, changes. This is a constant that never changes. Never. Yes. R is the constant for the gas law. That's what it represents. It's representing the constant for the gas law, for a real gas. Okay, I mentioned it, but apparently some of you didn't get the memo. Write these down on your periodic table now. You're going to need them on your next test. Because you remember this packet that I gave you yesterday, ladies and gentlemen? What don't you see at the top of it?
The constant.
Yeah, I'm not giving them to you. Just like I'm not giving you the formula for converting from Celsius to Kelvin or Kelvin to Celsius. But hey, you know what? I will be a nice guy, ladies and gentlemen. Cynthia's not even here to witness this. See these formulas at the top here?
Yeah.
They're on your test.
Thanks.
Wait,
You're
which
welcome.
formulas?
Oh,
The ones that are on top here,
The Charles and Boyle and...
Charles and Boyle's are not on here, but combined gas law is.
so you're giving.
Ideal gas law is. These exact formulas are on your test.
So only the combined and the ideal? We have to...
And the other ones that are on here. Well, Well, look at your version of it. I handed it to you yesterday.
So Charles.
I got one for you. Sorry. Yes. Thank you, Jasmine. If you weren't here yesterday, I got one for you. Sorry.
Oh, I found it, guys.
Far on. Here you go. If I got it for you right here. Look at there. Even has your name on it.
Wait, what are these other ones mean?
We haven't gotten to those yet. We will. We will. Okay.
So when you're doing those,
When we're doing these, yes.
I just like, I get it, but I don't get it.
Okay. Well, let
So
me
is
explain.
it like where we put our own numbers in and then we multiply and find out something else, or?
For now, can you get these onto your periodic table, and I'll show you how we'll use them in just literally minutes. Okay.
How should we write these down? Like, should we do like MMHG equals 62.4?
No. Here's what I would do.
Okay.
If this were me, but again, you could do this however you like. Somewhere on your periodic table, I would do R values.
Okay.
And then underneath, I would write 62.4 mmHg times liters over mole times Kelvin.
So we don't have to write
And then
down stuff in
underneath, I would
parentheses?
write 8.31 kPa times liters over moles times Kelvin. And then I would write 1.21 psi times liters over moles times Kelvin. And then I write 0.0821 atm times liters over mole times Kelvin. Now, I do want to point out one thing. Are these the only units of pressure in the world?
No.
So what does that mean?
That there's
There's
other
more.
R values.
Yes, and all someone would actually have to give you is what?
The base, like
The numbers.
The
You-
pressure.
yeah.
The pressure and the unit. Because what doesn't change in every single one of these calculations?
Everything else.
Yeah.
The liters is exactly the same. The mole is exactly the same. The temperature is exactly the same.
But wouldn't they have to give like the base pressure, like the
They would
standard
have to
pressure?
give you, yes, what standard pressure would be. There is a unit out there called torr, T-O-R-R.
Oh yeah, I found that.
760 torr equals 760 millimeters of mercury.
So it's the same.
So guess what the R value is?
The 62.
62.4.
But why would they do that?
It's just that there were two different units that were created probably in two different areas of the world. And when they brought them together, they realized, oh, we were representing the same thing here. We just called it a torr. You called it an mmHg. Well, we're not going to get rid of one. It's still going to be out there. It happens to be the same value. Okay? Happens to be the same value. But if I were to give you a different unit of pressure, you could find the R value for it. Because all we are doing is putting in all standard conditions. And the standard conditions are always the same. 22.4 liters for 1 mole. And standard temperature.
Would that be like one of our questions where you give us like a different one and we have to find it?
Ooh, don't take away that until you get a look at the test, okay?
Oh no.
Wouldn't surprise me if you had to calculate that on the test, yeah. I'd give you some unit of pressure that you've never heard of and ask you to calculate an R value for it. Might happen on question 4 of your test next week.
What if I memorize it?
Memorize what?
What if I memorize all the R values of all the different ones ever?
What if she puts them
Go
all
for
on
it.
her? On
I'll
her
bet you
periodic
can't
table?
do it.
Actually, I wonder how many is there? How many units of pressure is there?
Oh,
That's not an answer.
I don't honestly know.
Let me. I'm Google might now.
It's on. Hold on.
That's not helpful.
Why? What did it say?
It says pressure, barometric or not, can be expressed in many units. There are psi, newtons per square meter, inches of water, and inches of mercury, as well as the normalized bars and millibars, and standard atmosphere. So that didn't actually give me an answer.
No, it did. Google is terrible.
Yeah.
Google sucks.
There's like and then you know how it'll be like, oh, people are often asked too.
Yeah.
They'll be like, what are the 7 units? What are the 5 units? What are the 10 units? What are the 3 units? So how many is there actually?
You just look at it. There's at least 4 of them.
There's at least 10. I bet you he's gonna give us some easy. No,
Must
he's
have
not.
taken it with him. Mr. Arch used to have a book about yay big, about that thick, and all it was filled with was units. All different units.
That's not
Because
what
units
we're
have
gonna do.
every original culture had their own way of measuring things. And it wasn't until culture started coming together and we had to standardize things that we suddenly realized, oh my God, there were a billion different ways of measuring distance. Okay, maybe that's a little over exaggeration, but there were a lot of different ways that each different culture would measure distance. And we standardized that. We didn't say, all right, yours were stupid, we're getting rid of yours.
So then, are these like the 4 standard? or
These
just
are the 4
ones
most
like-
common, yes. These are the 4 most common that you will find in chemistry. Okay? But you did mention millibars, bars, instead of millimeters of mercury. Literally, the weatherman every day reports the weather in inches of mercury instead of millimeters. Why? Because in the United States, we don't measure in the metric system, we measure in inches. So when he says the barometer is reading 29.6, that's like saying the barometer is reading 760 millimeters of mercury. Okay? You could talk about inches or feet of water. You could put any liquid you want in it. So when you say, I'm going to memorize all the different units, you can't do it because there's some weird unit somewhere that somebody has that they're going to be like, all right, how about this one? And you're going to be like, okay. You might as well try to remember pi to the 573,000th digit. Okay? Ain't going to work out very well for you. Questions though?
No.
Okay. So now what this means, ladies and gentlemen, is we do not have to hold a single thing constant. And yet we always have something to compare to. Okay? This comes from this, correct? We did this with every single one of our gas laws. Every single one. Okay? But now, this whole thing here becomes that R value that we were just talking about. That R value. Now again, they call it ideal gas. And they put it all on one line for you. They put it all on one line so you don't have this over this. There's no accidentally solving for the reciprocal of something. Everything is on one line. It has been years, but I had a class that once gave this a nickname. They called it the pervert formula because of the PVRT. That's the way they remembered it.
Oh, is that the like base?
This is what ideal gas law is. Now, what it comes from is all of this equal to R, okay? But instead of putting PV over TN, let's multiply this side by T and N. What we do to one side, we do to the other, and this is the formula you get.
Why
This
do you
is-
put the N in the front? Why not the-
That's just the way they do it. That is just the way I've always seen it done, okay? So, again, the way it would be presented in a chemistry textbook, PV, then N, then R, then T. Again, I've never been told a reason why they do it that way. It's just that's the way it's always been expressed. Okay? Questions? All right. So now let's take a look at a problem, ladies and gentlemen. Boom. What pressure in atmospheres? Okay? So now they are going to ask you, if you're solving for pressure, they're probably going to ask you for a specific one so that it tells you which R value to use. Okay? If it doesn't, you could pick any one of the 4. But more than likely, my problems now are going to say solve it in a certain unit. What is the pressure in atmospheres of 0.108 moles sample of helium gas at a temperature of 20 degrees Celsius if its volume is 0.505 liters. Please understand, volume now must be in liters. Why? Because in our R value, the units are liters. And remember, we said it didn't matter what unit on each side, but they both had to be the same. Well, because in the R value, the unit is liters, in our problem, it has to be the unit of liters. Questions?
So we always have to, for ideal gas laws, we always have to get it into liters.
Yes. And temperature still has to be in
Kelvin.
Kelvin. Okay? So now, ladies and gentlemen, we've got PV equals nRT. Okay? Now we take and convert our temperature into Kelvin. Done that all along, still have to do that. Now we put everything into our formula. Pressure is what we're solving for. That's what it's asking for. Here's your volume. Here's your moles. Here's your R value. Why? 0.0821, because it is the R value for atmospheres. Which means when I'm done, what unit will my pressure be in?
Atmosphere.
Thank you. And here's your temperature in Kelvin. Now, what is this Kelvin and this Kelvin going to do? Cancel. What is this mole and this mole going to do? Cancel. And when I eventually bring this liters over to the other side to isolate my variable, to get P alone, what happens to liters? Cancel. Now, if you're looking at it strange, please remember, this is a division sign, so mole and Kelvin would be under liters in ATM here. So this Kelvin is on the top, this one is on the bottom of these units, they cancel. This mole is on the top, it cancels with the one on the bottom of this unit. Liters cancel out, we are left with atmospheres. You are left with atmospheres. When you do that math, ladies and gentlemen, there's your answer. 5.14 atmospheres. You don't have to hold anything constant anymore. Matter of fact, if they give you the conditions, you could figure out which one you're missing. How many variables in this formula? How many things are there to possibly solve for? How many things are there to possibly solve for? 5.
How would you solve for R when you already know the R?
Look, I was going to get to that.
Oh.
But this one, we know what numbers to use. But on the test, which one are you going to be solving for?
R.
Well, how? I give you a pressure. What do we use for volume? 22.4. What do we use for N? 1 mole. What do we use for T?
273 Kelvin.
273 Kelvin. You can solve for R here. Most of the time you won't have to, but you could. So of these 5 things, how many do you have to be given? You have to be given 4. You have to be given 4. Okay? You have to be given 4. Question.
So like, where that P, like the second equation, right in the middle.
Yep.
When you put that like without all of the different variables, is it just the numbers multiplied divided by 0.5?
Yes.
Oh, okay.
Yes. Now, again, units will help you set up problems.
Yeah.
Units allow you to figure out what something will be in. But in reality, ladies and gentlemen, this step right here, your calculator, punch in just the numbers. Punch in just the numbers. Okay? Now be careful. What would happen if you had 2 numbers on the bottom?
Put them in parentheses and multiply.
Put them in parentheses, one set of parentheses, otherwise you're going to get the wrong answer.
When did we have a number on the bottom?
Well, if you were solving for the moles here, to get it alone, you would divide both sides by R and by T.
Oh, yeah.
So it would come over to here. If you're solving for P or V, you're only going to end up with one thing on the bottom. If you're solving for moles or temperature, you're going to end up with two things on the bottom. So when you bring them over, that's going to happen. By the way, temperature's always got to come out in Kelvin. So if it asks you in degrees Celsius, you're going to have to convert it back at the end. Convert it back at the end. Questions? All right, let's take a look at another one. But yes, Sophia. And by the way, again, these three things are multiplied together. I don't like to put times signs in between when I have something like this because I don't like the way that looks when I set up the problem. So I put them in parentheses. Down here, yes, I put the multiplication signs in. You do not, when you put this into your calculator, need to put 108 in parentheses times the next number in parentheses times. Okay? You don't need the parentheses. You multiply these three numbers together, you divide by this one.
So
You would need no parentheses in this problem the way it is right now. Go ahead, Kayana.
So R is always gonna be like it's not just the number, it's also like cause like right there, you know how like for ATM, it's like the 0.0821.
Yep.
And then it's times ATM times liters divided by mole times.
Every number, even the R value, has a unit.
That's the unit
All
though?
this is the unit.
Oh.
Why? Because now remember, if we were to solve this for R, it would equal P times V over T times N. None of these units cancel each other out. So that is why all four of them appear here. None of those units cancel anything out. So because of that, this number actually has 4 units with it. But that's okay because in the formula where you use it, you're going to be multiplying it by other ones of those or dividing it by other ones of those. So your units, in the end, whichever one of these you're solving for, will be the one unit left over from here that you did not cancel out. Okay? Now, again, if you're not good with units, and I am not requiring you, when you set up the problem, okay, if you don't have complete units there, I still give you credit for it. As long as you have the numbers in the right places. Okay? Questions? How many grams of nitrogen dioxide are present in a sample that occupies 975 milliliters under a pressure of 75.6 kPa and at a temperature of 45.0 degrees Celsius? PV equals nRT. Which one are we solving for?
Mole.
But wait, I thought it wants grams.
We have to get it in mole.
Thank you. Grams and moles can be converted. We learned that in the last unit. So if it's asking you to solve for grams, it's really asking you to solve for moles.
And then we convert it into grams.
Then we can convert it into grams afterwards. What do we need to convert it into grams?
6.02 times 10.
That would get us into particles.
Atomic
Oh,
mass
yeah,
and
atomic
nitrogen
mass.
dioxide.
Or the unit formula units.
Formula mass.
Formula mass.
You guys were right there. We just didn't have quite the right words, but I know you knew what you meant. Okay?
I'm not
So again, we're going to convert our temperature into Kelvin. Why? Because we have to work this in Kelvin. What R value are we going to use here?
The KPA.
Which is
8.3.
8.31. Thank you. What else do we have to be careful of in this problem?
There's milliliters.
So what do we need to do to milliliters?
Multiply it by
We need to convert it into liters, which means we divide it by 1,000. To go from milliliters to liters, we divide by 1,000. Again,
Oh yeah.
I am not requiring you to show me either one of these two calculations, but I am requiring you to do them correctly. Because if you don't, your answer is going to come out way wrong. Put everything in. Here's our pressure. Here's our volume. 8.31. Why? Because we're in kPAs. 813 Kelvin. Here's a problem where you're going to have two numbers on the bottom when you isolate the variable of n.
Do we
Okay?
have to have like the variable n, or can we use can we just like write mole or something like that? Or do you want us to have n?
I would like you to use n.
Do we have to write the whole kPa times liters divided by mole times K, or can I do R?
Again. Well, you need to write this number. Don't put in R.
No, I mean the number, yeah, but can I
I am not going to grade you on units until your final answer.
So if we're
So in
solving
the
for R,
intermediate steps,
if we're solving for R,
If
it needs
you-
to be like that though?
what?
If we're solving for R, it needs to
Then
be like that, though?
then yes, that is the unit for R. Yes.
Oh, okay.
But if you in here don't write your units down and just put the numbers, okay, but just make sure you get everything in the right spot. You understand what I mean? Okay? So N is 0.02277 moles of nitrogen dioxide. Boy, I hope you remember how to write nitrogen dioxide. I really do. Because otherwise we're back to the last unit and going, well, I can't figure out the formula mass because I can't write the correct formula. Yeah, you're right. You're back to that again. Okay? You're looking at me like I'm crazy, KP. But there are still people who are struggling to write formulas for compounds. So now, 1 nitrogen, 2 oxygens. I'm a little bit more precise than most because I used the numbers that were off of another periodic table. Nitrogen would be 14.01. Oxygen would be 16. So again, you're talking about probably 46.1 instead. I'm fine with you using that. Okay. Yes, we are going to come up with slightly different answers, but again, because of rounding and things like that, I'm okay with that. But your answer better have 3 sig figs in it. Your answer better have the unit of grams.
If we have more sig figs, would it be marked like rounded up?
Yes, here is your final answer, correct?
Mm-hmm.
Okay, how many sig figs?
3.
So we just look at the.
That's all you look at. Yes, that is all you look at. In your
What
problem,
if there's one with 4?
whichever one is the least amount is what your answer is in. That's the rule for multiplication and division. That's why when we taught you that a long time ago, I said multiplication and division was easier because that's all you're doing. 3, 3, 3. Put your answer in 3. That's all you have to do. Okay? 3, 3, 3. Put your answer in 3. Yes.
How would the equation look like if we're trying to find R? Because if we're trying to find R, then we would need to know like the other.
R is P divided by Tn.
Okay.
Yeah, but like.
So we would take this formula. PV equals nRT.
No, not like the equation. I meant like the writing part of it, like at the top of the like page where you tell us like all the different numbers, because we're gonna have to know what like pressure.
So you
is.
want,
Okay, the problem would say, literally, calculate the R value given this pressure. And that's all I need to tell you.
Yeah,
Why?
you can just assume
Because you know what T has to be. What does it have to be?
273.
273. Can't be anything else. You know what V has to be. What? 22.4. You know what moles has to be. What? So the only thing I need to give you is the problem will literally say, calculate the R value if you use this pressure. And I'll give you a pressure.
What number?
Well, I'll have to tell you. So the unit is, or calculate the R value given a pressure of 21.6 brands.
What?
Calculate the R value. You could do it.
And you would literally just Wait, what number did you say?
21.6 brands.
So you just multiply 21.6 times 22.4, and then you would divide that by 273.
So, what did I give you for number? 23,
I thought it was 21.6.
21.6 brands.
You really want something named after you, don't you?
Shh. Well, yeah,
He's already got Raisin Bran.
I've got my kids, but I don't know how that's going to work. 22.4 liters,
Raisin Brans.
1 mole.
Can you dress up as a boxer Raisin Bran?
No, I don't have the right outfit.
What if
What if
I
I
buy
get
it
it?
And 273 Kelvin.
But don't
So
you
you
like a
literally
number
just
in
multiply
front?
that out.
What number in front?
Like on the other R values, you have like the 62.4.
Because that
Okay.
is the R value. So
Now, take 21.6 times 22.4 divided by 273.
I got 1.77.
Yeah, dude. Isaiah, turn your radio on. Are they gonna be made up on a test too?
Probably. Why would I give you something real?
So then that's the answer?
Yeah.
Oh. Wait, let me write this down.
That's how we get it. Why? It's all on that one slide.
But not like an example like that. With like the R. Because you don't have an example like that.
Okay. Okay.
So we're doing this on number 4 of the test.
Might be 5 on yours.
Can I just take a picture of this?
Why? Here's, guys,
Oh.
hold on.
But it's, we don't.
Sophia, you can just make up practice problems in your head. All you need to do is just like put a random number in your head, because all the other numbers we already know.
All I did was this and divided both sides by 1 and 273.
So those are the same, just like you just gave
So
us like a.
This is what I just did, except I put in brands as the unit of pressure here.
Oh, okay.
So this is literally how you calculate an R value. I didn't show you isolating the R.
Yeah.
Here's the formula, here's what you would get. Okay? So in reality, you're always going to have something times 22.4 divided by 1 and 273. Always. Always. By the way, no, we won't do, yeah, why not? Let's see if we can confuse you.
Oh no.
Don't go into the special gas relationship.
I'm not going to yet,
Okay, good.
but let's do this. Oh, let's see how good you are mathematically, ladies and gentlemen.
Not very good.
Pick a number. Pick a number. Mitzi, pick a number. What? Give me a third sig fig. 28.9. So this is our pressure.
M-A-K.
Sure.
Okay.
Okay. So what did I just set up?
Problem.
4.83.
Isn't it just 1 equals x over?
Oh, you
Because aren't those the same?
What do we call this?
You forgot to put the
In mathematics, what do we call this?
cross multiply.
No, we don't call this cross multiply. That's what you do to this.
An equation.
This is called a proportion. This
Oh, yeah.
is equal to this, correct?
That makes sense.
Why did I put 760 here and 28.9 here?
So you're not
So they could test
multiplying
them.
pressure.
Because they're both on the bottom, right?
Yeah.
This is the R value. What would I be solving for here? The R value for this number.
Yeah.
You could set it up as a proportion and solve it this way.
Really?
4.8.
Sure.
And that's the same as the other one you just did?
It's not going to be the same as the other one because this is a different number.
Yeah, but it's the
But I'll
same.
get the R value for this way.
And you could just do
That
that.
makes sense.
Sure.
That makes sense.
Oh my god.
Well, this R value over this should be proportional to this R value over this.
And we can use any of the pressures we want on the left.
Well, but whatever pressure you use, you got to use the R value for the appropriate one on the top. What?
Extra crazy.
Well, remember, the only reason I can do this is because I've already done these. Okay, I had to do these to get this number. But I could simply do a math trick of the R value over the pressure would be proportional to this R value over this pressure. You can find it that way. I don't care which is easier for you. Go ahead and do it.
4.8.
Do whichever is easier. Okay?
This one.
Questions?
Bro, just do that. I did that. I did the old one. Can't teach our old dogs new tricks.
Okay. Determine the temperature in Celsius required for 6.51 grams of sulfur trichloride gas to fill a balloon to 1.21 liters under a pressure of 0.988 atmosphere.
Is this using what we already what we just did?
Well, again, this is going back to the problems like we were doing just a minute ago.
Yeah, with the R and everything.
Good. So, ideal gas law. PV equals nRT.
So
Right?
we're solving for T.
So we're solving for T.
So pressure is
But when we look up at our numbers, what do we got to do first?
Grams.
What about it?
Grams.
So,
convert it to moles.
now in the last one, the last step we did was took it out of moles and went into grams, correct? This one, that's going to be your first step. We have to take the grams because we can't put grams into this formula. There's nowhere where grams go. And convert it into moles. Here is your formula mass for sulfur trichloride. 1 sulfur, 32.06. 3 chlorines, 35.45. That is what we get for the formula mass. We take that 6.51 grams, we divide it by this, we get this many moles. Okay? By the way, gases, especially when they aren't very big, what would 1 mole of gas occupy? How much space?
Depends on what it is.
22.4
Under standard conditions, sorry.
22.4 liters.
Okay, so if we're dealing with 1 liter instead of 22.4, that's about 1/20th. So don't be surprised if your moles are fairly small numbers. 1/20th of a mole. Okay? Something like that. Don't be surprised. Now we put everything into our formula. Here's our pressure. Here's our volume. Here's our moles. Why did we choose 0.821 or 0.0821? Because it's the unit of ATM over here. We got to use the R value that has ATM in it. Temperature. Solve it for temperature. Okay? Again, at this point, you don't need to write all the units. I do to keep my things straight. You don't have to. But you're going to take 0.98 times 1.21 divided by 0.0470 times 0.0821. By the way, if you do not put these in parentheses on the bottom, you're not going to get the right answer, which is 307.3 Kelvin. Don't leave it there. Put it into Celsius. Subtract 273, 34.3.
Would we just lose 1 point if we didn't convert it back into Celsius?
Well, you would lose 2 because the final answer needs to be in the unit of Celsius, not in the unit of Kelvin. And your final answer is always worth 2 points. 1 for the math, 1 for the unit in sig figs. So, question.
But what if we had it at like 307 Kelvin? That would be in the 360.
Correct, but that's not the final unit that I wanted in. So you still have to do one more conversion.
So you'd still lose 2 points.
Yes. Yep.
Are
Yeah.
they in special gas relationships, or can I run to the bathroom?
We're not going to do special gas relationships today, no. So hang on a minute. You can go in just a minute, okay? All right. Questions? All right. the packet that I gave you, ladies and gentlemen. Where would be a good place to start? I would start with number 11.
Why not one?
Why not 1? Because 1 needs a special gas law.
Whoa, I don't know those.
Oh my god.
So right now, you can do number 4. You can do number 6. You can do number 11. You can do number 12. You can do number 14. You can do number 15.
Can you write these on the board?
I will. But that's enough to get you started, ladies and gentlemen.
Which gas do they smell first? What? You can't do that?
I didn't say you could do that.
Oh.
I didn't say you could do number 2.
This isn't graded, right?
Is this
There's
not
extra
the second
credit.
packet?
I thought you said 15.
There's extra
There's
credit.
extra credit at the back, so this is not graded, correct?
Correct.
Which gas would you
Just
smell
making sure.
first?
Is that yours?
It's which one's the
There's a water bottle.
What?
Is this it? No.
That's it.
Okay, let's just start with 4.
Oh, Tay.
Actually, no, I want to start with 11 because it's
That's
one of
what
the
we just
R's.
did.
Yeah, that's right.
Yeah, that's the common one. That's the common one. That's common one. It's hard.
Yeah, but we can do it like this. How we did it.
Why is it so cold?
Yeah.
Oh,
Does R have a unit? Like, could I write R next to it?
These
so I
are
know
the
what it
units.
is? But like,
If you're solving for R, it needs to be like that. But if you're solving for like any other one, you can just put R next to it. He's not gonna grade you down for that.
Well, like,
Oh.
I know it's an R. Yeah.
I'm not ready. Equals X over.
So that's what we're finding. Which one?
Oh, shoot.
I got 2 people gone already. You're going to have to wait.
Yeah, just so I know what.
No, it was in Celsius.
But it was an occasion, it was on
Wait, for number 4, the CH4 is the formula for it.
I'm sorry. Which one?
For number 4,
Yes.
okay.
Yes. That because you wouldn't be able to write a formula based on the name methane, so I gave you the formula.
Okay.
Yeah, 2.4. 2.4.
Oh, I miss making Shanzi say
It was a mini.
Why does 7 and 8 have a little
You made
exclamation?
Shanzi say RMPD.
Or the.
You may have to think about them a little harder,
Wait.
but it's nothing you shouldn't be able to do.
10? You didn't say 10.
No, you're. So you're gonna
As I
find
went
those-
through, I might have missed it when I went through. I looked a little closer.
We don't do 15. Yes, I did.
Ooh, I
It's
don't
by
know if
three.
those are-
Three. So 2. You round the third number. Well, for this, yeah.
All you just find the R and RT. And RT.
And yeah. Can you come look at this?
Hang on 1 second, please.
I think he'll accept that, but I don't know. Is this how you want the answer to be written for R?
Yes.
Yeah?
Yeah. What we're saying is, when you're calculating the R, nothing can cancel. So you should always have these 3 units, liters, moles, and Kelvin, and then whatever unit pressure was in. Okay, always. So that's what all of your R value units will look like. They will be big and ugly because they're actually 4 units together that you can't cancel any of them.
We can go back. How many grams? So you have to convert it back to grams. Would fill. So. The 164 and yeah, we just use that one.